Hello everyone. In this video, we will discuss about Poisson distribution. Poisson distribution. If the probability P of a defined event is extremely small, or we can say rare event, in a large number of trials n done under the same conditions, the distribution of the various occurrences follows Poisson distribution. In other words, we can say when n tends to infinity and p tends to 0 means n number of trials tends to infinity and probability of success tends to 0 means rare events. The distribution is Poisson. That is Poisson distribution in the limiting form of the binomial distribution. This is one of the conditions. Poisson distribution, some rare events, some events are we can say rare. They means they don't happen often. Like for example, car accidents are the exception rather than rule. Over a period of time, we can say something about the nature of rare events like earthquake. Like as an example for understanding of the Poisson distribution, the improvement of traffic safety, where the government wants to know whether seat belts reduce the number of deaths in car accidents. So here the Poisson distribution can be a useful tool to answer questions about benefits of seat belt use. Some others examples are we can understand about Poisson distributions like number of deaths from a disease not in the form of epidemic such as heart attack or cancer or due to snake bite, so it may come under rare events like number of suicides reported in a particular cities or the number of defective materials in a packing manufactured by a good concern. So these such kind of the examples we can understand as a rare events. Few more like number of air accidents in some unit of time, number of printing mistakes at each page of the book. So there are very rare chance of misprinting or number of telephone calls received at a particular telephone exchange in some unit of time or connection to wrong numbers in a telephone exchange. So with help of these examples, we can understand possibilities of rare. So now we can define Poisson distribution. So the Poisson distribution is used to model the number of events occurring within given time interval. Like a random variable x is said to follow a Poisson distribution if it is assumes only non-negative values and its probability mass function is given by, always remember in my previous videos uh, explain whenever we are talking about probability discrete distribution, then we'll use probability mass function. Otherwise, if we are using continuous probability distribution, then we can say probability density function. So here we will read probability mass function of Poisson distribution with parameter x and theta. Random variable x can take a small x. Here e to power minus theta and theta to power x divided by x factorial, where x can take value 0, 1, 2, dot dot, and theta always greater than 0. So where theta is the shape parameter which indicates the average number of events in the given time interval. An important point in Poisson distribution, mean and variance both are equal to theta. So this is the basic information. This is the basic information about Poisson distributions. Thank you, everyone.